Okay, here's our first step. We're about to begin this process of making a double-sided part for our cabinet door. The first step is to go to create a new file. So we're going to go over here on the left-hand side menu, create a new file. The options we're going to get as they pop up is, okay, we have a couple of options up in the far upper left corner. We have single-sided, double-sided, and rotary. We're going to select double-sided, which gives us the opportunity to work on both sides of the part without having to set up another program. The part is going to be 97 inches wide. I'm setting it at 16 inches, although you'll see me cut it out of a larger sheet. And it's going to be 3/4 of an inch thick. It's also important because of the way I operate. I have to make sure that my machine bed is the 0 point, the Z0. And then I'm going to come down and make sure that my XY datum point is going to be in the bottom left-hand corner down here where the red dot is. Which way do I want to flip this part? I want to flip this part from the part that's on the drawing here, and it's going to end up over here on the right-hand side once I flip it. So we're going to flip it lengthwise. Standard resolution is fine here, and the material settings are fine. So we're going to go ahead and say, okay, that's the end of that step. So now we have a blank that will allow me to design or put in 3 doors. The first step is I want to import my door drawing. Now I use a different software, a piece of software, to design my cabinets. So I'm going to import a DXF file. That's on one of my thumb drives, and I'm going to go to the front side, bring that in, and there it is. So that's what the front of my shaker style door looks like. Let's just kind of look at this. This section is going to be eventually completely removed. These edges will be beveled all the way around, and there will be some small cuts that I'm going to make here so that it looks like a shaker 5-panel door when it's all finished. In essence, it will be a 2-panel door. Now the one thing I have to make sure is that when I put in the backside model, which is going to show up over here in a minute, that it's the same distance from the end. If this were at 2 inches and when I flipped it, it was at 1 inch, obviously the 2 halves would not line up. So I'm going to click on this part of the model right here, and I'm going to go to this tool here, transform, and I just want to see where it is. So I go to absolute positioning, and it's telling me that I am exactly 2 inches from this X end. That's what I care about for right now. The other thing I can do that will make this work is I'm just going to take this and I'm going to center this in the part. So halfway there. Now right up here on the top of the screen there is the flip. So if I flip here, now you'll see my part in that light green. That's just to help me line up when I work on the other side. So these aren't cutting vectors. So now I need to import the vectors for the back side, which is this DXF file here. Now they are going to line up, they should line up perfectly. Let's check that out. So I can see absolutely no variation. I can see that this little detail cut is going to be even with that edge. Everything looks really good. So I'm ready to go. So let's just review this. This is the back side. This section will be completely removed, and there will be a rabbet or a rebate, depending on how you want to pronounce that, around here. These are the pockets for my doors, my European hinges, and the rest is just cutting out the part. So we'll go up here and flip to the front view. Now we have the vectors we want to work on in the front, back view, vectors we want to work on the back. So now it's my job to decide what tool I'm going to use, how fast I'm going to cut, set up my tool library, and be ready to go with the next step so we can make this part. The next step would be to decide, well, I don't want to make just one door. Let's use as much of this material as we can. So on the front side, I'm going to grab this. Well, let's do this. Let's take a measurement And I think this is about 25 1/4. Yep, it's 25 1/4. So I'm going to grab this, and I'm going to use this little tool over here, which creates an array right here. So this lets me line them up. I'm going to have one row, so row is horizontal, and columns will be vertical. So I'm going to have 3 columns. And the offset has to be, if I'm going to do this right, about 26.25. That should give us a 1-inch gap in between. And whoop, that looks like it worked just fine. So now we've created 3 separate parts that we're going to get out of this. You can see from the little shadow here that I only have 1 on the back side. So we have to repeat that process here. And this is where I'm experimenting, trying to remember how to do this. So let's go here. But if we say here that our offset needs to be minus 26.25, then we should have created a perfect grid coming back the other way. And yes, we certainly have. So that's all looking good. Now I'm going to ungroup everything here. Oops, sorry, I got this problem with fingers that don't work quite right. So let's ungroup those objects. Let's flip to the front, and we will ungroup all those objects. And now we're ready to go ahead and start to create toolpaths. So there are probably as many different methods for doing this as there are operators. So I'll show you how I like to do it. It may not be what you've been trained or taught. It may be, you may have a much better way. I'm certainly not going to claim to know everything about this, but that's what we're ready to do next, is to start grouping these connecting these vectors and start deciding where I want my cuts, where I want them to be, and I'll show you a couple of cool tricks as we do that. Okay, now I should have done this before I did my array, because that would have saved me a few steps. But if we look at my drawing, these are grouped together, these are grouped together here. This is going to be the cutout. These are going to be my little V-carved details, so that I look like I have 5 panels. And these, you can see though, are separate. And so I should have done this before, but I'm going to hold down the Shift key, and I'm going to grab those, and I'm going to go over here. This is what I call the welding tool. They call it the join tool. So we'll join those, and now that's ready to work. If I did my array now, I wouldn't have to repeat that here, but I'm just going to quickly do that. Hope you're not too bored. So now we're ready to do side 1. Now what we're going to do is we've grabbed this pocket, or this rectangle. We've got 3 of these. These will be chamfered edge inset pockets when they're all done. We're not going to cut out the middle of the pocket. We're just going to cut the parts. So we're going to go over here, set up our tool path. I'm going to use a 60-degree bit. Mine is a large one for lettering, so it's 1 inch in diameter. I'm going to go inside of the lines. My depth is going to be 0.39. All right, we're not going to do multiple passes. We're going to be fine with a single pass. Then we're going to come down to ramp, and we're going to do a ramp on the inset. So we're going to ramp going into it. Angle 20 degrees is fine. That's pretty steep, but that'll get the job done. And then over here, if we click this button, we see corners. And so I can allow sharp corners. Well, that's going to give me what looks like a V-carved sharp corner in that edge, in the corner. And so it will look really nice and clean. There will be no rounded edge, so people will say, oh, you cut that with a router, because it's going to look like it was cut with a square tool, a chisel. So we're going to just say this is the inset panel. I always name all of my little processes, because I get confused if I come back a month later and try and change something. I don't want to have to do that. So that's my inset panel, chamfered edge. We'll calculate that. And when we go back and preview that, you can see all of those. If we turn the preview off, let's reset the preview and go back and look at this toolpath, and you can see those little blue lines in the corner, that's the ramps that are going to square up those corners. Okay, so back to the drawing. We'll start grabbing some things and moving along at a pretty good pace. Now these have already been connected together. These are, well, I don't want, let's start again. I do not want that highlighted, only these tabs. Now one thing that makes things easier, I don't know if you're using layers, but we could put all these things on layers and change each a layer, but layer for each individual type of component. Then you can switch all the other ones off, and you can just grab them all at a time, all at one time. For now, we're just going to go V-carve. All right, this is 80 thousandths wide, and that will determine how deep it cuts. So I don't have to do anything unless I wanted to start it inside of a pocket. So the start depth is 0, and that is basically, okay, we're going to call this the style. That's our little detail on the style and rail. Let's go back over here to our preview that. So, and if we preview the pockets, now you can see how perfectly those line up. First step, let's get the little details out of the way. So if we grab all these small holes, again, everybody's going to do this differently, but I pilot these with an 1/8 inch drill bit, 7 or 650 deep, and then I like to use stainless steel wood screws to hold my hinges in place. My hinge pockets are pretty tight. So this is going to give me where most of the mechanical strength is actually relying on the tightness of the hinge. So up here my tool is to drill. I'm going to go to select. I'm going to go find my drills. Here they are. I want to, there are my drills, and there should be an 1/8 inch drill there somewhere, right there. So a couple of things. When I'm drilling, drills are long, spindly, thin things, especially an 1/8 inch. If I tried to spin this at 25 or 24,000 RPM, there would be problems, things flying across the shop. About the best I can do is about 6,000 RPM. That's safe. Any faster than that's ridiculous, and your spindle will handle that without any problem. My plunge rate on this is going to be 40, and up here in my actual pass depth, this is how far it's going to drill before it retracts and starts again. Well, this is a small hole. I can go to 0.65 deep, and this is in my number 2 position on my machine. So I'm ready to apply that. Over here I'll tell it apply. Select. All right. Up here I'm going to tell it I want it 0.650 deep. I don't have a pocket, so I don't have a start depth. I'll put drill 125 holes in case I have to come back and edit this some point in the future. Now, there I go. Boom. There's all my holes. So those are my screw holes for my hinges. Back to the drawing. Now, when I built my prototype, these are just a little bit snug. All right. So I opened them up just a little bit. I just wanted to double check, make sure I had done that. I'm going to use the pocket tool here. So I'm going to go over here. I'm going to say cut out a pocket. This lets me do whatever I want with any bits, but my pocket is going to be 0.55 deep for my hinge. My tool is going to be a 1/2 inch bit. I'm going to use a 1/2 inch down shear, or actually compressions, because the down shear will be deep enough. So I'm going to go to, we'll use this one, and this is in tool number 1. So my speed about 18,000, my feed rate about 180, my plunge rate, I usually go about half of what my feed rate is. And I'm going to build my hinge pockets, so double check. All right, now this is going to raster or cut. It'll start in the middle and work its way out. If I do the raster cut, it will go back and forth. When I'm doing round pockets, I usually go this way. I also like to plunge my ramp moves. It's not necessary in most cases, especially in MDF, but we're going to use that ramp. And I'm going to preview that. And now you can see that we're getting closer every minute to being ready to go in the shop and cut some parts. Now, where I was getting to is we have these two lines that represent the actual small pocket that's going to be the rabbet for the panel to inset into, but because the 45 degree or not 60 degree cut coming from the back side is 380 deep and this is going to go about 0.4 deep, then they should merge to create a cut line right about where that black line is. That's the idea. Okay, so I've got a couple of choices with these, and this is the easiest. I like cutting the inside first, and I already have a 1/2 inch bit. There we go. I already have a 1/2 inch bit at work, so I'm going to stay with a 1/2 inch bit, and I'll have to select that. But there's my 1/2 inch bit. It's in number 1. Those are all fine. Here I'm going to go about 250 inches a minute, and I'm going to boost this to about 200 because I'm going to ramp these cuts. And so this is going to be on the outside, so in this area here, outside of that line, and our depth on this is going to be 0.4. And we don't have to deal with any of this. We're going to do a ramp. And that's just going to be a smooth angle ramp. And this is going to be that's the inside cut. So we'll calculate that. We'll go back to our preview. You notice I always pop back to the free preview and watch it work just to make sure I haven't put it on the wrong side of the line. Then a nice little trick is if you go, let's go back to the other view, get this out of the way. So you go to this view, this is an easy way to check your work. So this is a line, this is with the arrows, this is how I'm cutting that. So it's traveling, climb milling, but it's on the correct side of this line that I'm cutting, so I'm good. So now we just need to go back and select this one, and this one, and we're going to do the same, well, similar thing. We're going to cut inside this line to the same depth, the same bit. We're going to use the same ramp, and we're going to cut the so that's going to cut what we're going to call the outside. It's actually the inside of this pocket, but it's going to be the outside of the panel. And I'm going to calculate that, and we're going to preview that. So look at that. Because we already did that, see that little light show up there? That tells me my plan is working out just fine. When I cut this rabbet, I don't have to cut all this stuff out. All I have to do is cut that rabbet. Now it's ready for the panel. This panel is just going to lift out once I turn my vacuum off. Wow, getting close. Let's go back to this. Now here, I do this in a two-step process. Everybody's going to do this a little bit different, so bear with me. So I'm going to go up now. I'm going to switch to the same profile. I'm going to cut on the outside. I'm not going to use a 1/2 inch bit. I like 1/4 inch compression bits for this. And my 1/4 inch compression bit is a number 5. I'm going to go 18,000 RPM. 16 to 18,000 will do almost every job. I'm going to run this one at 300 inches a minute, and I'm going to plunge at 200. And now I'm going to do a couple of things. I'm going to come down here. We're outside that line. We're going to make an allowance that's another 30 thousandths or 030 outside the line. So it's not going to cut to the line, it's going to be a little bit away from the line by that far. Up here where we go for depth, I'm going to go 730. This is, or 720.72. This is a 750 thick. I want to leave behind a skin, just a real thin skin, a 32nd of an inch. That's going to hold my part in place. I will use ramps on this, and if I forget and don't use ramps or leave ramps on the next one, you'll know I goofed up. Do not ramp your finished pass. So this is my rough pass. So that's my rough pass. It won't give me the message you're going to cut through, because I'm not going to cut through, but I'm going to get really close. I'm also close to the line, but not on the line. This is a great tool here. I'll just use this for a second. It's called duplicate. So now I'm going to grab the same tool, everything's the same. Well, this is going to be 765 for today. We're going to use the same bit. We're going to do just one pass. It's going to go all the way through. We'll go over here and look at my setup for that tool, and my pass depth is bigger than that one, so we'll cut all the way through. Now we've already cut all the way through once. All we're doing is shaving away 30 thousandths from this edge that we cut last time, and this time it's going to cut all the way through to the table. So this is my finish pass. I will turn off the ramps. I want to make this right in one of the corners. So I go to the start menu and I say I want to start, this is move the start position, don't optimize it. I want to start in a specific corner. I want it to plunge there and then cut all the way around my part. And that will only be cutting out on the bottom, the 30 thousandths, and it will only be cutting, just shaving off 30 thousandths off the edge of my part. So I'm going to call this my finish pass. And we'll calculate that. This time I do get the message that says you're going to cut through the part. Did you know that? And the answer is, of course I did. So preview all of my tool pass. Drilled holes, pockets. Now this is where I can just review. I may have missed a hole and not picked one up or dropped one. This is where things could go wrong. If we go to the top view here, then I haven't previewed the other side, but this is where we would see that, where we saw that line. So this is where the two are going to merge and these parts are going to be waste. Okay, so I have completely programmed my parts. I'm ready to go in the shop, put these on a thumb drive, take them to my machine, and run these parts. We'll run the top side you see first, which is just the V-cuts, and then we'll flip the whole part over end for end, and then we'll cut out the other parts. All right, thanks for sticking around to the end. After I do the first basically detail cuts on this, I'm going to add one more line. This line is going to start just a little bit off the material. So about here, this is 0.33 from the end. And I'm going to run this line to just a little bit beyond the end of my material. So right down here. So that's about 97, just a little bit past the material. So then I'm going to go up here and I'm going to select my 1/4 inch bit. This is my 1/4 inch end mill. All right, I'm going to go 765 deep, so I'm going to cut clear through the material. I'm going to switch that to on the line here, and I'm going to say cut to 16 inch wide. So this is going to cut the first 16 inches out of my 4x8 sheet, and that will allow me to grab this end and flip it end for end so we can do the second side, which of course has this side here. I won't have to try and switch the long 4x8 sheet. I work alone, so being able to flip a 16 inch or 16 inch wide 8 foot long piece is easy. Trying to flip a whole 4x8 sheet, that's too much like work. We don't want to do that. So I've added that step to this, and now these are ready to go out, take out to the machine and get to work.